Good afternoon, everyone. Here is the same exact example that we did in class when we worked with classification. Um, I am going to open my file system and hopefully it will cooperate. And let me see, I believe I have it under assignments. Okay, I can take a look at that. And as you can see, we actually have considered candy and we had a few features. Excuse me. And because we said we only wanted the numerical values for x and y because we're going to be using k-means, so we only chosen the ones that have the actual values. Flavor doesn't help me. Sugar content is numerical, and the weight is numerical. So this is good, and these are the ones that we're going to be using for the algorithm. So here we'll go to cluster, and we actually choose a different algorithm because EM here is expectation maximization. So what we want to do is to choose a different algorithm. Yeah. So there is k-means somewhere here. Where is oops, clusters, simple k-mean. Yeah. So what we can do now is to we actually said we're going to have to experience with some distances and things like that. But we also said we're going to start with a cluster of a number of clusters of 2. That's k. Your k here is 2. But you're going to be doing k equals 2 and 3 and 4, I think, according to what the assignment is doing. And we also said that we can start the clusters from the points at random, but we also said we might want to use some of these guys too. Depending on your, I don't remember how your assignment was phrasing it, but I know that the assignment has asked you to also work with the initial condition as random and play with the cluster numbers. So I'm gonna hit OK here, and this is simple k-mean, right? And I should click on start, and this is going to tell me here the clusters. There are 9 points in cluster 0, and then 6 points. And then if we actually, I remember that we have even visualized that. It's been a while since I've taken a look at this, so let me see. Going back here, we have seen, let's take a look at the sugar content. Yep. And let's take a look at the weight right here. So these are your features that you're choosing. I don't know how to, don't remember actually how the visualization that we used. But let's go back. Let's go back to the, yes. Close here, and then I'm gonna have to try to run this one more time. And as you can see now, we are very mechanical here. Assignments, here's the candy. We choose the features that are numerical. Here are numerical values. As a matter of fact, if we inspect the file itself, which we can do, here is the file. I can open it with the text editor. And as you can see, those guys are numerical. Those are the ones that we're going to be using for x and y. Those are the only 2 values. So these 2 guys, 12 and 5, 8.2 and 42. Sorry. Yeah, I think so. Yeah, I think so. That's 12.5 and 35. I apologize. I can make it bigger so we can see it better. So we're going to work with these guys. The same example that we demonstrated during the classroom, 15 and 28. 9.5 and 33, 11 and 38. These are the exact same values that we're going to be working with. And that's the file that very similar to the one in your assignment. So as you can see, these guys are numeric values, and those are the ones that are going to give me X and Y values. I remember one of you actually said, Professor, how do we work with the with X and Y if the values are something like this? And I actually said, yeah, that's how we going to use these values. And I believe a couple of students have already answered this question during class. But I'm glad that you guys are asking again, because it's important that you are clear on this. Okay, so going back here, we chosen these two numerical values. All right, and then we're going to go to cluster again one more time. And then we are going to choose the algorithm that we want to choose, which is k-mean. Simple k-mean, that's what it is. Store, okay, let me see, and then we can start. And here are the results. And then basically the instances. I do not remember. Okay, right result. Let me see if we can. Yes, here it is. So if you right mouse click on the result, you can actually see the assignments of these points. So the blue points are the ones in for cluster 0, and the red ones are the one in cluster 1. It's not a very expressive visualization, but that's all you need to do. You can run your cluster, and then you can go back here, click one more time, and then you want to run the cluster equals 3, and you push again, and then you will see that we are creating 3 different clusters here: cluster 0, cluster 1, and cluster 2. Let me try to visualize cluster assignments. And as you can see, we now have 3 different values, 3 different clusters here. And we could also close this visualization, and we can run this one more time, and we can do 4 clusters here, and we run, and as you can see, 27%, 27%, 27%. These are the first 3 clusters, which is going to give me 80%, I believe. And then the last one is more or less. Yeah. And then the last one represents 20% of the points. And the visualization is not very exciting actually, but let me see if we can, visualize them one more time. And as you can see, we have 4 different clusters here: cluster 0, cluster 1, cluster 2, cluster 3. And this is good. Now the other type of experiment that we want to do is to make sure that we also play with the randomness and use a different parameter. Let's see if this is going to make any difference or not. But we also want to make sure that we start the experiments again from scratch. So we do clusters of 2, and then we run, and you will see here that those guys add up to 100%. 7 plus 8 is 15, and we can take a look at the clusters, and you will have to compare these results with the previous results, because the initial condition is different. The initial condition here using k-mean plus plus, but the previous one was, as you can see, the previous one was a random. So these are the parameters that we have to play with, and then we have to continue to observe. So now we tried k-means plus plus, which is the initial condition, the initialized method. We can also run this with 3 clusters, and then we push start, and then we get these results, and then we visualize, now 3 clusters, and then I can run this one more time to 4 clusters with the exact same initial condition, so I can have a point of comparison. And then I push start, and now I have, actually in the previous cluster this was 27, 27, 27, and then 33. So you might wanna report these things and how they are different in each algorithm and each setting, in each initial condition. So let me see why this is not working. I want to, yeah, here it is. I want to visualize, and here we have 1, 2, 3, 4 clusters. Okay, all right. I think this is good. All you need to do is basically play with these parameters and report each as you can see, when you have 3 clusters, report the percentage. Here you report the percentage of 47 versus 53. So you're gonna have to have 6 experiments. The first one runs k-means at random. That's gonna give me 60 and 40. And then if we run it again with the other one, with the k-mean plus plus, is gonna give you 47, 53. So you see there is a little bit of a difference here. So this is k-means with a random specification for 3 clusters, and this is k-means with k-mean plus plus initial condition, as you can see, also 3 clusters. So you might want to just report the number of instances and the number of clusters. Feel free to follow this demo, and make sure that if you have any questions, you give yourself enough time to get back the result, and do not wait until the last minute, please, for your own sake. All right, I hope you enjoyed the video. I hope you found it helpful, and I also hope that it takes away the stress, and you can get your assignments done on time. Alrighty, I'll see you in class.